and welcome to another edition of RockSim Live. I'm your host, Tim Van Milligan. We are live on Facebook right now, and we've got a whole bunch of people here. I want to say hello. Joshua Drummond, Ralph Strausser, Wes Munn from South Carolina. That's a new name that I haven't seen before. Brian Barbalis, Ron Kaminsky, Joshua Petrovich, Rick DeFosses. Oh, we got somebody, and I can't pronounce your name. He says he's from Algeria. I asked him if he's really from Algeria. So if you really are from Algeria, yeah, it's so cool to have you. It's awesome. We are a global community here with RockSim users, and I really appreciate it. If this is your first time using I've got a monitor over here. That's why I keep looking off to the side over there. If this is your first time using RockSim, let me show you where you can download it. So here on my web is our Apogee website, apogeerockets.com. I forgot to make my cursor big again. Let me do that real quick, because sometimes I can move my cursor around so fast that you can't see where I'm pointing to. So if I make my cursor big, then it's easier to track where it is, because it's just big giant black thing moving around. So there's my cursor. If you're new to RockSim, it was just last week we released RockSim version 10.3, which is right here. So you can click on that, and that will take you to where you can download it. You can download the free trial version right there. And if you are upgrading from 10.2, you can do that here on this page as well. Here is how to get the upgrade. The link to the free upgrade is right here. Let me do a poll here real quick. How many of you watching right now have already gone and upgraded to the latest version, 10.3.1, which we released last week? So if you've updated, go ahead and say that you did, so that I kind of have an idea of how many people we have that have updated. We do archive these videos, these how-to tutorials, and if you've never seen them before, if you're watching this on YouTube, I'll show you how to get to them so you can see all the ones that we've done in the past. So you go to the how-to and guides on the apogeerockets.com webpage, then come down here to software, click on that, and then over here is RockSim Live Training. And if you click on that, it'll take you to our live training page. And this is a bonus episode. We're at number 25 this time. Because this is our last one from last week, was episode 24. So now we're on 25, which is, I think it's quite an accomplishment myself. We've got some questions here coming in on RockSim. And that is the purpose of us here today, is to answer your questions. And first we have Joshua Petrovich from Grand Rapids, Michigan. How do you account for fin fillets? And can RockSim simulate side-mounted boosters? And I can answer both of those questions pretty easy. Well, the first one's easy. The second one takes a little bit more time. We have Joe Batera from Michigan. Joe Noble coming in. Yes, we indeed have Africa in the house from our person in Algeria. Don Thomas is here. Joshua Petrovich says, I upgraded. Al Anzik says, yes, he updated. Joseph Dunning says, yes, he updated. Rick DeFosses says, yes, he updated. Joe Batera, Ronald Zacher, Joe Noble. Ron Kaminsky says, waiting until the weekend. And Ralph Strausser says, yes, he updated to 10.3 yesterday. So it looks like a majority of the people in the house have updated. So now that I know you updated, tell me how you like it. I want to know. Is it doing the things that you want it to do? Yeah, so we are running version 10.3 here on the desktop. And let me do this too. We are going to give away a free poster, and it looks, I'm going to do the first one that asked the question again, just like we did last week. And it's Joshua Petrovich from Grand Rapids, Michigan. He wins the, let me turn on the main screen here so you can see it. We are giving away to Joshua a autographed, I've autographed it down here near the smoke. This is an autograph photo poster of the Antar, and this is not an Apogee kit. This is an Estes kit. And the reason we're making a poster of the Apogee kit is because this is going to be the cover of the next Peak of Flight newsletter. And if you're not a subscriber to the Peak of Flight newsletter, I'll show you how to do that here in just a second. But this is what the poster looks like and what the cover of the newsletter looks like. So that's the Estes Antar. The newsletter is going to be a really special issue. We have, I forgot the name of the person that designed this rocket. I did not design this rocket. This is called the Snake Eye, and it's modeled after a bomb that the Air Force uses. And what happens is the fins pop out and they create a drag recovery. In my book, Model Rocket Design and Construction, I talk about drag recovery. And there's not too many models that use that technique of recovery type. You know, there's parachute recovery and streamer and helicopter and glider. This is drag recovery. And this rocket uses that. Let me show you how it works, because you're going to get a really good kick out of this. When the ejection charge goes off, it's going to kick out the motor with a little streamer on it, but also at the same time, it's going to slide the nose part forward, so it's going to split right here. The nose goes forward, and when it does, it releases the fins, and this happens like really fast. So it goes whoop. Isn't that cool? And there's a lot of 3D parts that are inside here that you have to print out, and we're going to provide the files because that the designer did provide. I am so sorry I forgot the name of the designer because I want to give him credit. But you'll download this issue next week on Tuesday, and then you can get all the parts, or you have to print out the 3D parts. But it's an Apogee nose cone, BT80 size body tube. Everything else is stock except for the 3D printed parts that you have to print. And there's close to 50 different parts to make this rocket kit. It doesn't look like there's that many, but there's a lot. And to make it go back down, I've got to push on the outsides together. And then it slides back together like that. Oops, I don't have one of them in. Unfortunately, you can't model this in RockSim as a recovery device, but you can model it on the way up. The fins, you see they're kind of split here. They're supposed to be together like this. This is what happens when you don't use a fin jig to build your rockets. Your fins can be kind of cocked. They're straight, but they're kind of at an angle when they should be straight up. So use a fin alignment jig when you're building rockets to solve that problem. So let's get into RockSim, because that's what you're here for. So Joshua Petrovich wants, how do you account for fin fillets? So that is fairly easy. Let's open up a design. Let's see if I can, we have the Estes Antar. We're going to feature that. I want to thank John Bourne. He provided me a model. I actually built it, or actually I refurbished this, and because the original build wasn't quite up to our standards, so I said I'll make a video on how to refurbish this. So that's going to be coming up in our advanced construction videos. Let me type in Antar and see what comes up. Antar rocket right here. I've got several versions here. Let's open this one. So here is the Estes Antar. And so Josh was asking, what happens when you put a fin fillet on there? Well, you have to account for the mass. The fin fillet mainly affects the mass. It's not going to affect the flight of the rocket so much. So to account for the mass, what you'll do is you'll go here to Rocket Design Components, and you need to place what's called a mass object on the rocket to account for the mass of the fillets. Say if you're using heavy epoxy fillets, that could be some significant weight. That could be, you know, anywhere from 3 grams to 20 grams if you're really heavy on your fillets and the size of the rocket. So for instance, on this rocket, I would say let's put them on the body tube. So when I highlight the body tube here, you can see down here in the new version, RockSim 10.3.1, it tells, you know, it kind of highlights it down here so that we can see what we're working on. And then I'm going to come over here to Mass Object. I'm going to click on Mass Object, and it always looks in the database first. And so you can cancel out of that because we kind of are going to figure out what our mass object is. So right now we're looking at the back view of the rocket, and I can change views right here. Currently the mass object is right there. Let me make this a little bit bigger so you can see it. So the mass object is at the front of the tube, and we can change the location of that mass object anywhere along the rocket we want, and then just give it a mass. So if I want, you know, basically what you're going to have to do is build the rocket, weigh it, and if your rocket here in RockSim, you have the weight right here, and if this doesn't match your rocket, say my rocket weighed 70 grams instead of 66.779 grams, so I need to add more weight to it. And so what I would do is I would balance the rocket out on my finger. So it's kind of like, you know, a little bit behind the leading edge where it attaches to the tube. It's going to be like right there. So I would adjust the location. So my location is right here right now. Let me change it to top view. So I would like to put it like, it's almost going to be like right where the current center of gravity is. So I'm going to take my mass back here, the M, and I'm going to take the slider and I'm going to slide it right there. And I'm going to give it a mass. So we said, so this is going to be like 3.3 grams, somewhere around there, just to get it up to 70 grams. So once I hit my tab on my keyboard, watch this number right here. So I'm hitting the tab right now. See, and it jumps right to 70 grams. So that is how you account for a mass like fin fillets on your rocket. Okay, so then his second question is, can RockSim simulate side-mounted boosters? And the answer to that one is yes as well. Save your changes? No. Okay, so we have a rocket here, and say we wanted to add some StrapOn boosters to this rocket. We've talked about this topic before, but I will go over it again, but I will show you where you can find more information, because I'll just cover it real quick here. So if you go to this RockSim Live training, that page that I showed you earlier, and then on your keyboard, do a Control F, or on the Macintosh, it's Command F, and it brings up, right here at the top, it brings up a Finder window that's specifically looking on this specific web page. So now we can type in strap, and it's not finding anything. Boosters. It's finding 3 boosters. There's 2. Where's the third one? Booster recovery stage on parachutes. Maybe we called this pods. Okay. Nope, only one time we did pods. I'm sure we've done it before. But that is how you would find if we've done a topic that we're not covering today. You would come here to this page, because like we said, we got 25 episodes and we've been talking about so many things. But let's go ahead and add a pod then. Okay, so let me look at this in the base view. So here on the base view, I got to figure out where I'm going to put my pods. Normally, because of these wings, it kind of limits me on where I can put it. So let's open up a different design. Let's take the Estes Big Bertha. Okay, so here's the Estes Big Bertha, and we're looking at it again in the base view. So I would probably put one pod here on this side of the rocket and one pod here on this side, because you want to kind of balance them out. And okay, so first we got to figure out where we're going to attach them. So I'm going to attach it to the body tube. Let me go to a side view. Okay, so it highlighted that body tube. And then we're going to come over here to what's called a pod. So a pod is a collection of parts that is strapped to the outside of the rocket. If it's on the inside of the rocket, you wouldn't use a pod, you would use what's called a subassembly. And we talked about subassembly, I think it was last week. So this time it's going to be pod. So I'm going to click on pod. And what it's doing right now is it's telling us it wants to create a pod, and it's asking us where do we want to put it on the rocket. And right now it's right here at the front of the nose cone. So this little icon right here kind of gives you an indication of where it's going to be on your rocket. And I can slide it back, and you know, let's slide it back like right there. So that's good. And if we look at it in a base view, it's on the side of the rocket. And we're going to adjust this later, but right now we just kind of seeing where it is on the rocket. So I'm going to click OK. So when you come back to this screen, it's not showing, which is okay. But here it is in the parts list right here, pod. And now we're going to start attaching parts to this. So basically we're going to start a new rocket on the side of the current rocket. So we're going to start with the nose cone. And again, it always looks in the database. And let's choose an Apogee nose cone because we make some pretty good products. So I'm going to choose a PNCA 24 millimeters. So that's what that stands for. Plastic nose cone, 24 millimeters. And A stands for the shape. We have several shapes with the A shape, the B shape, the C shape, and the D shape. That's just only what it means. And then click OK. And if you really want to find it, here's the part number for it. If you type in this part number in the search feature on the Apogee website, you would come exactly to that page. Click OK, and you can see it attached something there. And let's look at it in the side view. So there's the nose cone attached to the rocket right there. We can look at it in 3D as well. And zooming in and then just kind of rotating it around. You can see it's interfering with the fin right now. We'll move this, so don't get concerned at this point. It's just a placeholder for right now. If you like all the parameters other than its location, click OK. So now we got that, and now we're going to add a body tube to this. And so highlight that new nose cone, and then click body tube. And again, it's looking in the database, and I need a 24 millimeter tube, and there's one right here at the top. Click OK, and you can see it added it to the side of the rocket. And rotate it around. It's interfering with the fin, but now we need to adjust the length. Let me go to a side view here. So we got this long tube, and I'm just going to take that tube and slide it shorter to get it to kind of near the base of the rocket, like right there. And then we can change the color. Instead of being red, let's make it white. Click OK. Okay, so now we have the tube there, and now we want to put an engine inside of that. So we need an engine mount tube in there. So we're going to go inside tube. We're going to make it an 18 millimeter tube. Click OK. You can see now we have this tube inside. We're going to shorten it up. And 2.75 inches. That's just kind of typical for a rocket. And I'm going to slide it back to where I want it in the pod. You can see as I'm moving the slider, it's sliding it back. I'm just kind of moving it slow here. Okay, so I'm going to hang it out the back just a little bit. I don't have much room for a streamer, but I probably could get one in there if I wanted to. So I'm going to change the location from the base of the owning part. And that just tells me it's 1/4 of an inch hanging out the back. Let's change the color of that as well. Let's also make that white. Click OK. So now we have a tube. Now we need to add some centering rings. So now I'm going to add my centering rings to the body tube here. Centering rings. You notice that I'm not changing the names of the parts. I should be. I'm just being lazy today. With this new feature on RockSim where you can click on it in the parts tree and it just finds it for you, it's a lot easier to find parts. That's why I'm being a little bit more lazier. So here's a centering ring I'm going to add to this tube. We're going to choose a 13 to 24 millimeter. Oh, no, we need an 18 to 24. 18 to 24. If you don't know the exact size, you can just click up here. It'll automatically calculate the known values. And then what it will do is it will automatically pick the outside diameter and the inside diameter. So you don't have to do it. The only thing you'll have to specify is the thickness of the ring. You know, how long it is or how wide or thick it is. And then I'm going to choose the location. You can see I'm sliding it back. Let me zoom in here. And to zoom in, you can use the scroll wheel on your mouse to zoom in. And then you can click and drag and move this image around so you can see it a little bit better. So here's my purple centering ring. And I'm just moving it over to the engine tube right there. And it's material paper. I can change the color if I want. I'll just leave it for right now. And that's what I'm going to change the name of this one. I'm going to call it the forward centering ring. Click OK. So there's the ring. Now we need another centering ring at the back. So I'm going to come over here, highlight it, and click. I'm going to right click on it, and it brings up this little menu here. I'm going to do copy. I'm going to come up here to the tube and click that again, right click, and then paste. And now we have a second centering ring, but it pasted it exactly on top of the first one. So now we have to move it and rename it. But sometimes this can be a little bit quicker doing it this way. This way. Aft centering ring. And now I'm changing it. Let me change it from the base. Let's change it 0.25 inches. That should. So here. Come on, grab it. So here is the base of the part, and it's kind of recessed into the tube 0.25 inches. And click OK. So at this point, we have our pod. Let me just save this design here just in case. File, save as. I'm going to throw it on my desktop. That's this Big Bertha with pod. Plural. We only got one right now, but so here's our pod that we've created. But the problem is that we haven't fixed yet is it's on top of this fin right here. So now we got to slide it. So we need to slide it around the tube this way. And to do that, we'll come back up here to the pod. I'm going to double click on it to open up the pod. And then I'm going to click on the radial position tab here at the top. And I want to look at a rear view of the rocket so I can see where exactly it is. And so now I got this slider here, and I can just slide it around. And I know it's going to be exactly 45 degrees, so I'm just going to type in right here in the radial angle, 45. And so now it's exactly 45 degrees, so it's exactly between two fins. And I'm going to click OK. Let's go back to the 3D view. If it's ghosted like that, that means it's searching for a part. So just click off of the rocket somewhere. And if you click a part, it's going to highlight the part. And if you click off of the rocket, then the whole rocket is in view. So here's our pod right here. Oh, the other thing that we can do, I don't know if we specified this or not. I'm going to open up the pod one more time. And it says, up here, there's a box that says, this pod can be ejected during simulations. So we expect this pod to fall off. Say you're using the StrapOn booster hooks. What's a StrapOn booster hook, you ask? So if you come back here to the Apogee website, and this time in this search bar, not in the one up here, because that was specifically for the page. So this is for the entire website. You type in strap, and let's see, and it gives us some options here. And we got the flying machine, which actually uses the StrapOn booster pods. But here's one right here, StrapOn booster pods. I'll just click on that. And what it brings up is a list of everything in our website that has the StrapOn booster pods. And you can see StrapOn booster pods right here, and we have replacement hooks. So if I click on this, if you wanted your rocket in real life to drop off those pods, this is what you would have to use. You'd have to have something like this, where you have the pods on the outside, which what we just showed how to design. But it's these little hooks at the front and the rear that make all that happen. So here's the hooks. Here's the front one. Here's the rear ones. If you come to the Apogee website, you can see what these look like and how they work, in case you wanted to design something similar on your own. Okay, so let's get back to RockSim. So make sure that it is, if you want it to fall off, make sure it's checked. If you want it, say it's glued on permanently, uncheck that. So now it can't fall off. This one here below it that says mark this pod as ejected. Say you wanted to find the center of gravity of your rocket without the pods on it. I could come up here to this box. When I uncheck it, this should go away, kind of like it fell off the rocket. And see if I come back here to the main screen. Come on. There we go. So now if I look at my rocket, it's been ejected. It's still there. It's still in my parts list. If I come back to it, I can uncheck that again, and now the pod will show back up on my screen. Come on. There we go. Okay, so now we are, we need another one. We need another one on the other side. Now, so we could go through the exact same steps of creating that pod, but we're lazy and we want a fast way of doing it. So I'm going to show you the fast way. And we kind of hinted at this earlier. So let me just double click on it and save it real quick. So I'm going to highlight the pod right here, and then I'm going to do a right click. And we're going to do a copy. So we've copied it to the clipboard, and now I'm going to come up back here to the body tube, and I'm going to right click on that and say paste. Okay, so now it should have pasted a second pod, and sure enough, now there are two pods on my rocket, the first one that we made and the second one we made. And where's that second one? Because we're not seeing it here in the screen. Remember when we did that for the centering ring? It pasted it exactly on top of it. So this pod is exactly on top of the first one. So I need to move one. So I'm going to double click on that one. And how do you think we're going to move it? Come there to the radial position and just slide it around. You can see it separated quite easily. So I need to go 100. Let's see, 90 plus 45 is 135. 135 degrees. Okay, so there's the pod. Click OK. Now we have two pods on our rocket, and we're ready to run a simulation. So I'm going to save it real quick. And let's go and load some motors into this pod and see what happens when we launch it. So, it's like, okay, something happened here. Why am I not seeing these motor pods? Tim forgot to designate the inside tubes as engine mounts. So let me cancel out of that. So now I got to go to my pod, and I got to find that inside tube. This is where it really helps to name things. But here's one of them, and here's the little checkbox that says this is a motor mount. Let's check that. And it's going to be an 18 millimeter diameter, so we just confirm that. Click OK. That was one of them. Here's the other one. This time I'm going to change the name of this. Let's call this engine mount tube. And check the box that says this is a motor mount tube. Click OK. So now we're back here to the main screen. And let's load that motor this time. Say now it's showing up. Now I got 3 motors in here. So let's choose engines. And let's choose an Estes C6. And we're going to need a long delay because it's going to go a lot higher with 3 motors in it. My engine overhang, I'm going to change that to 0.5 inches. Click OK. So it loaded the engine in the center one, and if I come over here to my screen, you can see it down there. There it is, loaded. And now if I want to load them into the other pods, I'm just going to highlight that motor and say load all, and it just loads them all into the other 2 pods on the side of the rocket. Flight events, we're going to deploy the parachute at maximum ejection delay. Simulation controls, leave that alone. Starting state, it's launching straight up, 36-inch launch rod. Launch conditions, these are our standard conditions. And let's see the flight profile, see what it looks like. Make sure that our rocket is indeed going straight. So here's the 2D flight profile. We always look at this because this gives us a good indication of what this is, applying human intelligence to the flight. So our image, this background image, we can't see the ground. If I come here to preferences, I can uncheck that box there that says maintain the image shape. Click OK, and it should reload it. And it basically just stretched the image so I can see the ground. The background image in RockSim doesn't really mean anything. It's just an image in the background. It's just kind of give you a visual indication of where the rocket is. So here's the rocket sitting on the launch pad, and it's aimed straight up. We click launch, the rocket takes off, and it's flying high, and it's going well. And then the parachute pops out. The problem here is that we're not seeing the pods fall off. And this is a limitation of RockSim. And then the parachute is descending back down to the ground. But you can get, so did the pods actually fall off? And that's what we want to confirm. So if you can't see it in the 2D flight profile, how do you confirm that those pods actually fell off? Okay, so here is our simulation results. Let me just move some columns around so we can see things better. So we have 3 C67s. Okay, so now this is human intelligence again. With 3 C67s, all the motors are going to eject at the exact same time, right at when the parachute comes out. So we're not going to see the pods falling off on the way up. To see the pods falling up on the way up, we need to change the delays in the side-mounted pods. So instead of being C67s, let's make them C60s. So I'm going to go back here to simulations. I'm going to change this first one to a 0 second. These are the pods. Make sure when you click on them, it's highlighting it up here. So when I click on this other one, it highlighted right here. We chose a yellow color for the 2D color. That's why you're not seeing them very well. If it would have been a red color, you'd probably see it better, but that's the color that we chose. So I'm going to make that a 0 as well. And let's look at the flight profile one more time. Running the simulation. And pretty much the same. We're still not seeing the pods fall off down here, but that's typical. Parachute comes out at 7 seconds, and then it descends to the ground. So here's the two simulations. The optimal delay has changed. And our maximum altitude has come down. That's interesting. When the pods fall off, our altitude is lower. Why would that be? You would assume that with the pods on the rocket, there's more mass, which is true. The rocket is heavier, so it's not, because of that, what we're thinking is that it shouldn't go as high, but with the pods staying attached. But since the pods are falling off, the rocket is less weight, it should be coasting higher, but it's not going as high. So why is that? Is there something, you know, the first thing that people say is there's something wrong with the program. I can almost guarantee you there's nothing wrong with the program. If you would look, I don't know if you noticed it when we looked at the trajectory, but I'm thinking back in my mind right now. Let's go back to that trajectory. Look at it one more time and see if we can see what's going on. So as the rocket takes off, you can see it's kind of arcing into the wind a little bit. And what's actually happening is it's arcing more into the wind than if the pods had stayed on. With the pods on the rocket, our center of gravity has moved way back. And so now it's closer to the center of pressure. And because of that, the rocket is less stable. And because it's less stable, it's not going to weathercock as much. So that is the reason why it didn't go as high. You're learning some rocket science here, if it wasn't obvious. You just have to think about it. You have to look at the pictures and figure out, well, what's going on here? If RockSim is right, which it is, why is it doing that? And now we have the reason. So let's also confirm that the pods did fall off. So I'm going to go to the graphs here, bring up the graph for this rocket. What I'm looking at, I don't really care about acceleration, so I'm going to clear out acceleration. Oops, I hit the wrong button. Clear that. Let's keep velocity, but let's keep it total velocity. I also want to show thrust, and I want to show mass. So we're looking for the mass of the rocket. So here is mass right here. So we'll select mass, and let's end the graph data. We're going to modify this in just a second, but right now it's set for the end of the data, and let's plot the graph. And here's our graph. And at this point, it's kind of hard to see because all the important stuff is right here at the beginning. And to see that, you can zoom in on it. And you can click and drag. What I'm looking for is mass. And it's really hard to see. But right here, so because it's hard to see, this is why I'm going to go back to the preferences. So I'm going to end the data at 5 seconds. So it's going to take this area right here and it's going to stretch it out through the entire screen. So I'm going to go back here to preferences, end the data at the flight time of 5 seconds, and I'll replot. So now it's stretched everything out. So now I can see things a little bit more clearly. So I'm looking at the mass. So at liftoff, here was the mass up here, which is somewhere between, about 175 grams. And then what happened? So as the rocket started burning, we're losing mass. We're losing propellant. So that mass is this line, this diagonal line right here. But then something happened right here at burnout. All of a sudden, we dropped a massive amount of mass. And that is the pods falling off. So the pods fell off right there. So that confirms that the pods did fall off. And then once they fall off, our mass stays constant all the way until the ejection happens. And well, I'm not seeing the data anymore because I got to go back to my preferences at the end of the data. And let's see, at when the first recovery device is deployed. Let's plot that. Okay, so this is what we saw before. So here's the rockets coasting upward, and then right here is the ejection. And so all the way up here, our mass is staying the same. So now let's compare that to the previous one, where the pods didn't fall off until ejection. So let's plot that one. Same thing, plot this. Okay, so now remember before, right here at burnout, we lost a lot of mass. And now we're not losing that mass here at burnout. They're not falling off. So they're staying attached until ejection. And then after ejection, well, now we're out of data. We need some more data to see. So now let's look at all the data. Okay, so then here is, so, you know, here was ejection right here. And then all of a sudden we lost a ton of mass. So that's where those pods fell off. Okay, so that was a really long-winded discussion of creating pods that fall off and how to control when they fall off. Let me see. I'm going to check my monitor over here, see if there's any more questions. Rick DeFosses says, I really like the part of the highlighting too. That's cool. Joe Noble says, do you have a RockSim model of the Antar? Joe, if you come to the Apogee website, you type in Antar here, it brings up this, and you'll notice that that image is the same poster that we're giving away. And if you come here to the Antar and you scroll down right below the price, you click on RockSim file, it jumps you down to the bottom of the page, and this is where you can download the Antar file. So that answers Joe's question. I have had not chance to go through anything new in the version yet, says Rick. Al says, can you go over defining colors in 3D so the image is opaque and not semi-transparent? Okay, Al, we'll go over that. Rick DeFosses, can RockSim predict the landing location of multiple recovery devices like the flying machine? As you saw, Rick, RockSim cannot, but Roxen Pro can. And I'll show you that in just a second, because I always like showing off Roxen Pro because it is so much fun to play with. Joshua Drummond says, I'm building a custom level 1 CERT rocket as I'm watching. So he's building a rocket while we're talking here. Don't get sawdust on your computer, Rick. Well, that was Joshua. Don't get sawdust on your computer. Al says, you answered my question. Just click off the part to see it opaque. Yes, that's correct. Joshua Petrovich, thanks for that information. That's awesome that RockSim can handle all of that. So Al, I'll answer Al's question. So Al's question is, for some people, clicking on a part here can be bothersome, and then knowing how to click off. If you go to the RockSim preferences on the Macintosh, it's under the RockSim menu. On Windows, I believe it's under the Help menu. You'll find preferences for RockSim, and what you'll discover is there's some new check boxes. One of them is there's one in 2D and in 3D, where you can enable or de-enable 2D part selection. So that's where it was on 2D, and then on 3D it's right here. So if I uncheck here and click OK, now when I come over here and start clicking on parts, it doesn't highlight them. So I can't enable, so now finding that tube coupler it doesn't highlight it anymore because I turned it off in preferences. So if you're not seeing this, it's because you've had it turned off. By default, it is on, so you have to turn it off. So I'm going to go back here to 3D rendering and enable 3D part selection again. Click OK. And so now when I click on things, it will highlight them. So now I got that ring. If I click on body tube, there's the body tube, and I click on the nose cone, there's the nose cone, and click off of that to get the whole rocket selected. Okay, so now going back to Rick's question, and this is where I get to show off Roxen Pro. So let's save this design one more time. So it's saved. I want to bring up Roxen Pro. I'm going to open that design that we just made. It's sitting on my desktop. Big Bertha with pods. Click open it. You have saved changes. Say no, because I know I just saved it. So here is the same rocket that we've just made. Now this is Roxen Pro. You can tell up here at the very top it says Roxen Pro. This Roxen Pro has not been released yet. We are just mere weeks away from releasing it. This is the build I got yesterday, so this is the latest build. We've tested it on Windows. So far, everything's working just fine. In order to release this yet, we have to build in our website some special features, because Roxen Pro is not like RoxSim where it's one price and you get it forever. Roxen Pro is subscription based, so you pay by the month. And there's a reason for that, is because there's incurring cost every time you use it to me. Because there's maps that I have to pay for. So we're going to be charging by the month. So here's the simulation that we just did, the C67, C60, C60. I'm going to load those engines, and a quick way to load engines, you can do this in RoxSim and in Roxen Pro. So if you've not heard about Roxen Pro before, it's identical to RoxSim except for the way it runs simulations. So designing a rocket is identical from what we've just seen that I did when I created this design. So I'm not going to go over the design part anymore. So where it's different is when it runs simulations. Instead of running it just as a 2D flight profile like we saw, we're going to run it in 3D. And we're going to run it from our launch site, or a launch site we pick, anywhere in the world. So now the background image is critical. Now we can see exactly where those parts are going to land. Like they're going to land in a forest or in a stream, or in last week we landed in somebody's pool. I will never be able to land in a pool again. It was just so cool. It was just random. So I've loaded no, I haven't loaded the engine. So if you right click on the engines, I can set load engines, and now it automatically loads them down here in the rocket. So I've loaded them just as we did before, but now I'm going to go to the prep screen. Again, we've got the engines loaded, the Estes C6s. Everything is the same so far. The flight events, we're still going to deploy the parachute at maximum ejection delay. Now our starting state is where it starts getting a little bit different. So the same launch guide length, same launch angle from vertical. Before I think we were launching straight up. So let me turn this to straight up. Now we have an azimuth angle. And an azimuth angle is like a compass direction. So here's our compass. Straight up will be 0 degrees. East is 90. South is 270. And south is 180, west is 270. If you're launching straight up, the azimuth angle doesn't matter. It's only when you deviate from vertical that now the azimuth angle does matter. So now we're angling the rocket, and currently we're almost straight west, or straight east, I'm sorry. So that is what's different here. Launch conditions. Under launch conditions, this is where we select our launch location. I have chosen this site. I am not sure exactly. It's the Cato launch site. These are random launch sites that I picked, where I've actually gone and put in the latitude, longitude, and elevation of the launch location. And no, I'm not seeing it. I'm sure it said Cato. I'm just going to click cancel because I ran this morning, and the cool thing, and I'm now running the flight profile. The cool thing was at the launch site, the aerial photo of the launch site was taken when an actual rocket launch was going on. So here, no, this is not it. This is not the launch site that I was thinking about. But here is the launch site. So here's the rocket sitting on the pad. Okay. And you can kind of see one strap-on booster, and I can rotate it around, find the rocket. So now you can see our two strap-on boosters right there on the side of the rocket. This down here is the same view that we're looking at, and if you want to turn it off, you can turn it off here. And this visualizer, we call this the launch visualizer. It has 4 different views, 4 different camera options. So right now we've got the camera option is selected of keep the rocket exactly in the center of the screen. No matter what happens to the flight, I only want to see the rocket. The second one is I want to see the trajectory. So keep the camera focused on the same scene no matter where the rocket goes. So in this case, the rocket, it could actually fly out of our screen, but that's okay. It's as long as we know that's our camera view. And then there's 2 other camera views. There's a camera view of the camera above the rocket and looking down the side. It's kind of like your camera was mounted on the side of your rocket, but we had to cheat a little bit. We had to put the camera a little bit above the rocket, like right here. And the camera will always follow the rocket like this. So that's that one. And then this last one is ground observer. And this is kind of like real life situation where you're on the ground watching your rocket take off. So that's ground observer view. I find this one here to be the most useful. So that's the one we selected. So the rocket is right down here. And we have, like we do in RoxSim, we have a weathercocking cone. We want the apogee point of the rocket to stay within this 30-degree cone. Okay, so if you ever lose where the rocket is, there's a button right here that says find the rocket. And it will center in the exact middle of your screen. So if you drew a diagonal from that corner to this corner and the other corner, right in the exact middle is where the rocket is. So it's right there. And if I zoom in, I can see a red dot. And if I keep zooming in, there's the rocket. But that's too close of a view because I want to see the trajectory. I want to see where those pods fall off. So I'm trying to kind of aiming it around. So in this perspective, the north is okay, now I lost my perspective here. I'm moving it around, so north is straight up. So north is straight up this way. And remember, we angled our launch rod to the east at a few degrees. So let me spin this around. And I'm using my mouse. You can also do it here with this controller. Okay, so our rocket is down here, and now we hit the launch button. And the rocket's taking off. You see the smoke coming out. The rocket's taking off. It went out of the view, but that's okay. What I want to see is where those pods are. So let me pause it right here. You can see there's 2 green dots. Well, that's where that was the highest point that those pods ever made it, where they fell off the rocket. So if I zoom in here, I can kind of see there's a kind of a green line coming down. So at the base of those green lines, I should see my pods. Oh, they're further down than I thought. Where are they? Oh, they're already on the ground. So you can see down here, I'm continuing to zoom in. So there's where the pods fell off. And so to kind of get a perspective of where they fell off, so here was our launch point. They fell off close to this first tree. And they fell almost straight down because we had no streamers in them. And then the upper part is still up in the air at this point, and it's still smoking. The smoke hasn't dissipated yet. And so now the parachute is out. If I zoom in here on the parachute, let's click Find the Rocket, puts it right in the middle. And then if I just hit the plus sign, I can zoom in right in on my parachute. You can see the pods have fallen off of the rocket, just like we expected. Just like real life. Find the rocket. Let me zoom out. So that's like really cool. So this is Roxen Pro. So now Roxen Pro is harder to use than RoxSim because setting up the simulations is a little bit tricky. So we have another product right behind Roxen Pro that we're going to release. And today's your special day. I'm going to show it for the very, very first time. So I need to bring up a window here. And this new program is browser-based. And I need to move my browser off the screen here. I need to set this up, so I need to kind of hide it. I need to hide the URL right now because once people get the URL, they can actually play with it, and we're not ready for people to start playing with it yet. So I need to make a couple of adjustments here. Let me close here this screen. Save this, make Roxen Pro go away. Let's see. I can't see if this is coming up. Okay, yep. Not quite hidden hard to find enough. I don't know if you saw that. You weren't supposed to see that. Come on over here. Okay. Okay, so this is the launch visualizer software that we're working on. When you first come to it, you will come to a screen like this. There's already a rocket preloaded on the screen, and this is the Apogee Avion. And you can choose a design, any design you want. Right now, there's only a few of them loaded. There's also user designs that users can save. But since I'm not logged in, there's no user designs because it doesn't know which user is logged in. So I'm just going to click cancel. I'm just going to leave the Avion. And you can see the rocket sitting on the pad. And if I make this screen a little bit bigger over here, we can see which direction the wind is coming from. And this is full 3D as well. So right now we have wind coming from the west, blowing towards the east, past our rocket as it's sitting on the launch pad. It's kind of cool, right? Okay, so now if I come over here to starting state, there's this button right here. Click on that. Now I can start adjusting the rocket. This visualizer can actually do some things that Roxen Pro can't do, because Roxen Pro, I'm not being able to see the rocket as I'm making adjustments. So I have a launch angle from vertical. Right now it's launched straight up. I also have the azimuth. This time we've made it an actual compass. I'm going to angle it to the east so that when I adjust the azimuth, you can actually see it, because before, north is straight ahead of us, so north is up towards the horizon. And so if I angled it, I would just be angling it away from us, and it's kind of hard to see. But if I adjust the azimuth to the east and then I angle it, now you can see that the rocket actually does angle like that. And now I can just start spinning it around the compass. And so now you can see I can adjust where the rocket is going. Yeah, pretty cool, huh? And as you can see, I can angle it even downwards, which for most flights would be pretty quick because it's straight down. Okay, so then when you got the rocket going the direction you want to go, then you could select your, let me log in here, because if I log in, now it will remember who I am, and it will remember different launch sites. So I am still same rocket, and I got the same launch angle. It should be bringing up an image right here, which it's not. Oh, the humanity. Yeah, it's got a bug. Somebody must be working on the back end right now, because this was working just a few minutes before we actually started, because I wanted to show you this. Because I can select my launch site here, choose a launch site. Let's see what happens. Yeah, it's not bringing up my launch sites. Oh, here we go. Yeah, there was one called Cato. Let me see if C-A-T-O. Cato Rocket Club. Click that one. Yeah, it's still not bringing up my image. Okay. Well, we'll try to show this next week. So I'm going to close it. Yeah, so we are actually out of time anyway. So let me go here to our outro screen. Let's see if there was any last minute questions. If that's Cato in Connecticut, I joined them, says Joshua Drummond. Cool. It might be. I can't tell you without it working for me. Joshua also asks, so can the Roxen Pro 3D trajectory view also account for wind in either a manual entry or by grabbing the current wind conditions from the internet? And the answer to that is yes and no. Let me go back to Roxen Pro real quick. So can Roxen Pro account for different wind conditions? And the answer is yes. If you come here to the wind table, this is where you would enter different wind conditions. So right now I have the wind at 0 degrees above sea level and 20,000 feet above sea level at a constant direction of 270. So that's from the west at 8 miles an hour. So if I wanted to change that, see, this is where Roxen Pro is a little bit harder to use, because you got to think, it's like our launch site here in Colorado is 5,400 feet above sea level. So my base elevation where the rocket takes off is at 5,400 feet. So when you get a wind from the internet or something like that, or you're using an anemometer on the ground and you got 8 miles an hour, that is actually at 5,400 feet. So I'd have to type in 5,400 feet based on where I'm launching from. But if I change my launch location, and if I don't change my wind table, now what it's actually saying is at 0 miles an hour at sea level and 8 miles an hour at 5,400. So somewhere between those two numbers. And so if my launch altitude, if I'm on the East Coast near sea level in Florida, my launch altitude is 10 feet above sea level. So now my wind speed is going to be really slow instead of being 8 miles an hour. So you always got to remember, you got to check your launch site location with your sea level altitude. So it's a little bit more complicated. So Roxen Pro, what we want to do is get everybody using the online visualizer, but there are some people where Roxen Pro will come in handy. So entering a custom wind speed is, yes, you can enter it right here. Can you grab it from the internet? And that was his second question. And the answer to that one is no. We don't have a way to import wind data from the internet. There's a website called windy.com that has wind speeds at different altitudes, but they charge a fortune to get their data, to import their data. So we're trying to find a cheaper alternative than windy.com. It's a great website. I recommend it. You know, if you need this data right now, that's exactly where I would recommend that you go. Just grab it from their website, but you have to hand type it into this location right here. So this is really cool to play with, because you can actually make a spiral wind pattern. And if you look at your rocket starts doing this as it goes up, just because the wind interacting with it. It's really cool. I really love playing with Roxen Pro. It can be really enlightening as to what's actually going on with your rocket. But I really need to quit because we're 5 minutes over time. We are going to, all this time, I forgot to turn my screen on. So all this time you didn't see the my wind table. I forgot. Man, I am such a... yeah, I got to remember to do that. So if you go to prepare for launch here, and then go here to wind table, this is what I was talking about, where you would type in values in a table form. Okay, sorry about that. I got to remember to change screens. I got to change screens over here on this monitor. You know, and I forget to do it. So now I am looking at this monitor over here, this camera, because we need to quit. So what I was saying is we are going to be switching from Facebook Live to YouTube Live, and we hope to do that next week. And we will send out an announcement. We will post it on Facebook. We just have to confirm that everything's working on YouTube before we say officially that it's going to be on YouTube. We're testing this out to seeing if you people out there would rather watch it on YouTube than on Facebook, because there's a lot of people we know that don't like Facebook. They don't want to join Facebook. They don't want to have anything to do with Facebook because Facebook gathers so much information, personal information. When your friend likes you, you had nothing to do with that, but Facebook grabbed that data. So there's people that don't like that. We understand that. So that's we might switch to YouTube permanently. We're going to test it out first to see if it's working. So episode number 26 should be live on YouTube, and then we'll archive it. We'll archive it on Facebook, as well as we do archive these on YouTube as well. Okay, so we have to quit. I need to bring up a different screen here so that I can quit this video. So I'm going to quit this video in 5, 4, 3, 2, 1. Go out and launch something.